Hello everyone. Welcome to this tutorial series on getting started with ML agents in Unity. Whether you're looking to create intelligent agents for your games or simulations, or you're simply curious about how AI can be applied in game environments, you're in the right place. So what is ML agents? Simply put, ML agents is an open source toolkit from Unity that allows you to train intelligent agents using machine learning, specifically reinforcement learning. This toolkit helps you develop complex behaviors, enabling your game entities or characters to dynamically adapt and learn from their environment. ML Agents has recently been updated to version 3, bringing a host of new features and improvements that make it more powerful and easier to use. So, there's no better time to dive in and start learning how to use this toolkit. This video is part of a mini-series that takes you through everything you need to know to get started with ML agents. From setting up your environment to running your first AI agents in Unity. I'll assume you already have a recent version of Unity installed on your PC and are somewhat familiar with it. In this tutorial series, I'm using Unity 6 on a Windows 11 PC, so please be aware that some steps may vary if you're using a different operating system. In today's video, we'll focus on getting everything set up. We'll walk through how to install CUDA for GPU support, using Anaconda to manage your Python environments, and of course, getting ML agents itself up and running. By the end of this tutorial, you'll have everything installed and ready, and you'll be able to run Unity's basic ML agents example project. So stick around and let's get started. Before we dive into the setup, I want to mention that this tutorial is guided by Unity's official ML agents installation instructions, which you can find here. It might be helpful to keep this page open in your browser as a reference while I walk you through the installation process. You'll find a link to it in the description. Next, on Windows, ML Agents requires Microsoft's Visual C++ Redistributable to be installed on your system. If you don't have it yet, you can download the latest version from the official Microsoft website using this link. Scroll down the Downloads page and locate the installers. Click on the x64 link to download the required version. Now, go to your Downloads folder and run the installer. Accept the license terms, then click Install. Click Close to exit the installer. With that taken care of, let's move on to installing the CUDA toolkit, which provides the tools necessary to enable GPU acceleration for ML agents. First, it's important to note that CUDA is not essential for running ML agents. If you're only planning to use your CPU for training, you can skip this step and move on to the next chapter, where we'll cover installing Anaconda. However, if you have an NVIDIA GPU and want to speed up training times significantly, CUDA will enable GPU acceleration. To install CUDA, first make sure your system meets the requirements and that your GPU is CUDA compatible. You can check this on NVIDIA's site at this page. As an example, click on GeForce and Titan products. This will bring up a list of GPUs and their respective compute capability scores. Generally, any GPU with a compute capability of 6 or above should work well with ML agents. Once you've confirmed compatibility, the next step is to head over to the CUDA Toolkit Downloads section. However, instead of downloading the latest version, you'll need to install the specific version of CUDA that's compatible with the version of PyTorch that we will be installing later. But what version of PyTorch do we need? If we look at our installation instructions, we find this line. The Q121 at the end refers to CUDA version 12.1, meaning we need to download CUDA Toolkit version 12.1. Please note, the PyTorch and CUDA versions mentioned here were correct at the time of recording. However, they may have been updated since, so always refer to the latest installation instructions to ensure compatibility. Let's return to the CUDA Downloads page. Go to the archive of previous CUDA releases. Select CUDA Toolkit 12.1.1. You should be taken to the version download page. Select the Windows operating system, the x86-64 architecture, Windows version 11, and finally, the local installer type. In the Download Installer section, click the Download button. Once the download has finished, go to your Downloads folder and run the CUDA Toolkit installer. Click OK. Click the Agree and Continue button to accept NVIDIA's license agreement. With the Express installation selected, click Next. Once again, click Next, then close the installer. Now that the CUDA toolkit is installed, the next step is to install cuDNN, which helps improve the performance of deep learning frameworks like PyTorch. cuDNN is NVIDIA's GPU-accelerated library for deep neural networks and works alongside CUDA to optimize training. Head over to the cuDNN download page, link in the description. Before we download cuDNN, let's check that this version is compatible with CUDA 12.1. We can check version compatibility on this page. As you can see, version 9.5 of cuDNN does indeed support CUDA 12.1. With that confirmed, let us go ahead and download cuDNN 9.5. Once the installer has finished downloading, run it and follow the on-screen prompts. Okay, with cuDNN installed and integrated with CUDA, we can now move on to the next step, installing Anaconda. In this tutorial, we'll be using Miniconda, which is a lightweight version of Anaconda. We will be using it to set up a separate Python environment specifically for ML agents, ensuring that dependencies don't interfere with other Python projects on your system. Go to the Miniconda download page. Scroll down and click on the Windows installer. Go to your Downloads folder and run the Miniconda installer. Click Next. Agree to the terms of service. Click Next. Click Next again. Under Advanced Installation Options, I will uncheck Register Miniconda 3 as my default Python, as this is not necessary for our purposes. Click the Install button. Follow the prompts to complete the installation process. Now that we have Miniconda installed, we'll use the Anaconda PowerShell prompt to set up a separate Python environment. This isolated environment will be where we install ML agents and its dependencies, keeping everything organized and independent from other Python projects on your system. To find this Anaconda PowerShell prompt, click on the Start icon in the Windows taskbar. In the search bar, start typing Anaconda PowerShell prompt. You should see Anaconda PowerShell prompt appear in the search results. Now, while we could simply click on this to open the terminal, I'd like to show you how to create a shortcut to the Anaconda PowerShell prompt on your desktop instead. Right-click on Anaconda PowerShell prompt and select Open File Location. This will take you to some Start menu shortcuts. Simply drag the Anaconda PowerShell prompt shortcut onto the desktop. Close the File Explorer. Before we continue, let's briefly explain why the training component is implemented in Python, even though Unity uses C#. Python is one of the most popular languages for machine learning, offering powerful libraries like TensorFlow and PyTorch that simplify AI development. ML Agents uses PyTorch, running in Python, to handle essential tasks like training, data processing, and updating the agent's model through reinforcement learning. Reinforcement learning is a type of machine learning where agents learn by interacting with their environment and receiving rewards for achieving specific goals. PyTorch manages the complex calculations involved in this learning process, while Unity provides the environment where agents interact, learn, and adapt in real time. This setup lets Python handle the training side, while Unity manages the visual and interactive parts of the simulation. Okay, let's get back to our tutorial. With the Anaconda PowerShell prompt shortcut ready on your desktop, we'll use it to create a dedicated virtual environment for ML agents. This environment will keep ML agents and its dependencies isolated from other Python projects on your system. Double-click on the Anaconda PowerShell prompt shortcut. A PowerShell terminal will open, ready for your commands. Please note, since we will be typing a series of commands, I've added a link in the description to a text document listing all the commands we're about to execute. According to the installation instructions, we're given a single conda command to create and activate a virtual environment. In PowerShell, we'll need to split this into two separate commands to achieve the same result. In the terminal, type the following command to create a new virtual environment named ML Agents with Python version 3.10.12. Enter Y to proceed. Now, we need to activate this environment. Simply type conda activate ML agents. Notice the ML agents label in brackets before the command prompt. This indicates that we are now working in the ML agents virtual environment. We will now start installing some packages. First, we'll install NumPy, a fundamental package for numerical computing in Python. NumPy is required by both PyTorch and ML agents. The current version of ML agents uses NumPy 1.23.5, so we will install that specific version. Enter this command. Enter Y to proceed. Next, we will need to install PyTorch. If we take a look at the installation instructions, we find this line. The command will install PyTorch version 2.2.1 with CUDA 12.1 support. Copy this command exactly as it is and paste it into your PowerShell terminal. Then press Enter to run it. By the way, if you want to run ML agents on your CPU only, you can install PyTorch with the following command instead. Okay, now that PyTorch has finished installing, let's test to see if it's working correctly. First, let's start Python by typing Python and pressing Enter. Once Python starts, type import torch. Let's test NumPy also. Type import NumPy. Let's check the version numbers of these packages. Type the following to get the PyTorch version number. Now type the following for the NumPy version. If you haven't encountered any errors, then both PyTorch and NumPy are successfully installed in your environment. Type exit brackets to exit out of Python. Let's type clear to clear the terminal. However, do not close it just yet. Now we will install ML agents. First, we'll copy the ML agent source files to your PC, and then we'll use this local copy to install ML agents in our virtual environment. To get the source files, open a browser and go to the ML agents GitHub page. Scroll down and find the Releases section in the sidebar. Click on the latest release. Scroll down the release page and find the source code zip. Click on it to download the source code. Once the download has finished, go to your Downloads folder and copy the ML Agents zip file to the folder where you keep your Unity projects. Extract the zip file. Once extracted, you can delete the original zip. Rename the extracted folder to ML-agents. The extracted folder contains a local copy of the ML Agents Python package, which we'll be installing shortly, as well as an example Unity project. Okay, let's get back to our Anaconda PowerShell terminal. The first thing we need to do is change our directory to the ML Agents folder that we have just extracted. Enter the following command, replacing the directory path with the location of ML Agents on your system. You should now be inside your ML Agents folder. Let us quickly refer to the installation instructions for the next step. To install the ML Agents Python package from our local source files, we'll need to run the following commands. Let's execute the first command. And now the second command. Wait for ML Agents to finish installing. Now run the following command, ML Agents -learn -help. If you see this help readout and there are no errors, then the ML Agents Python package has installed correctly. Okay, we are going to move on to setting up the Unity side of things now, but leave this PowerShell terminal open. We will come back to it later. Open Unity Hub. I recommend that you have the latest version of Unity 6 installed, as we are going to use this for our ML Agents projects. With projects selected in the sidebar, click the Add button. Select Add Project from Disk. Find that ML Agents source code folder that we extracted earlier and double-click it. Inside the ML Agents folder, you'll find a folder named Project. This is a Unity project that contains several demo scenes using ML Agents. Select the Project folder, then click Add Project. Now in the Projects list, select Project. A window may appear, warning that you are trying to open the project in a different version of Unity than the one it was created in. Under Installs, select the latest version of Unity 6, then click Open. Confirm that you want to change version. You will likely get another window popping up, warning that the version change may require a re-import of assets. Click Continue. Here's yet another warning dialog. Click Yes for these and other files. Eventually, the project should open in the Unity editor. The first thing we will do is take a look at the Package Manager. Go to the top menu bar and click Window, and then Package Manager. In the Package Manager, select the Unity Registry category. Then in the list of packages, find the ML Agents package. With ML Agents selected, you'll see that this project is already set up to reference our local copy of the Unity package. If we were starting a new project, we could of course install the package directly from Unity's servers. In that case, there would be an install button here allowing you to do this. In any case, we will leave everything as it is. Close the Package Manager. We are going to run a very basic example scene in order to test our setup. In the Project panel, go to Assets and expand the ML Agents folder. Next, expand the Examples folder, then open the Basic folder inside it. Finally, within the Basic folder, locate the Scenes folder and open the Basic scene. In this scene, the agent is represented by the blue cube character here. It sits on a grey platform where it can move either left or right in each frame. In this basic scenario, the agent learns to move left or right to reach a target that provides a positive reward. The agent is penalized with a small negative reward for each move it makes, encouraging it to reach a target efficiently. One target yields a much larger reward than the other, so the hope is that, through training, the agent will learn to move directly toward the most rewarding target. Anyway, let's get back to our project. Keep the current Unity scene open and switch back to the Anaconda PowerShell terminal. We are now going to fire up the training backend of ML Agents. This is done by using the mlagents-learn command. In order to train the basic example that we have open in Unity, we are going to use this command specifically. But don't type the command just yet. I'll break it down for you first. The first argument in this command is the path to a configuration file, which defines certain parameters for the training algorithm. These parameters help tailor the training process to better fit our specific scenario. Note that this is a relative path, meaning it's specified relative to the directory we are currently in. If you locate the basic.yaml file in the File Explorer, you'll see there are also config files for other example Unity scenes. We won't go into the specifics of these files right now though. The second parameter in the mlagents-learn command is the run ID, which assigns an identifier to the training session. You can choose any ID you like. Alright, let us now execute this command. If everything goes well, you should see a large ASCII Unity logo appear, along with a message prompting you to press the play button in the Unity editor. Let's go ahead and do that. Keep the PowerShell terminal open and switch to the Unity editor, which should still have the basic scene open. Press the play button. Unity should now connect with the Python side of ML Agents, and training should begin in real time. You should see the agent, the blue cube, start moving, very erratically and randomly at first, but gradually becoming more purposeful as it learns to move directly towards the larger target. One thing to look out for: check the console panel. If you see a couldn't connect to trainer message, then Unity has not connected with the Python backend, and training is not taking place. Instead, the agent will have switched to inference mode, where it is no longer learning but simply running off a pre-trained AI model. Anyway, let's stop the training and switch back to the Anaconda PowerShell prompt. The terminal should display several messages related to the training session we just exited. You should see a printout of the training parameters, along with lines tracking the progress of the training session. If you've reached this point without any issues, we can safely say that ML Agents is set up correctly. However, there's just one more thing I'd like to show you before we finish. If you try to reuse a run ID that was previously used for a training session, you may see this. In this case, the training backend has refused to run, and you'll see this message: use --resume to resume this run, or use the --force parameter to overwrite existing data. I've decided to append the --force parameter to the end of my mlagents-learn command. Keep in mind though, that this option will overwrite any previous training data. As you can see, the Python backend starts without a hitch this time. Okay, that concludes this tutorial. In upcoming videos, we'll take a closer look at some ML agents examples to gain a better understanding of how everything works. After that, we'll develop our own ML agents project from scratch. If you found this tutorial helpful, please like and subscribe for more ML agents content. Goodbye for now, and I'll see you in the next video.